Is the financial system safe from a computer that doesn't even fully exist yet? Seriously, think about that for a second. Right now, the entire global economy and the literal trillions of dollars secured by our current cryptography is facing an existential risk from a technology that is still actively in development. The fundamental math that protects our bank accounts, our private data, and our institutions, well, it's standing right on the edge of a monumental shift.
Welcome to This Explainer. If you're here to understand exactly how emerging technology is fundamentally reshaping our world, you are absolutely in the right place. Today, we're going to dive into a step-by-step masterclass on how quantum computing threatens the global banking sector, and, much more importantly, exactly how we can fix it.
Okay, let's dive into this. Here is our syllabus for today. 1. The quantum financial threat. 2. The harvest now, decrypt later strategy. 3. The quantum cryptography toolkit. 4. Real-world banking pilots that are already in action. And finally, 5. The quantum migration roadmap.
All right, Section 1, the quantum financial threat. Let's lay the groundwork for why the digital trust we rely on today is about to face an absolutely unprecedented challenge.
To really understand this threat, we have to look at one fundamental difference. You see, classical computers process information using bits. They're strictly two-dimensional, existing as either a 0 or a 1. Think of a classic bit like a coin just resting on a table. It's either heads or it's tails. Simple, right? But quantum computers, they use qubits. Thanks to quantum mechanics, a qubit can exist in a state of superposition, meaning its value is both 0 and 1 at the exact same time. It's like a coin constantly spinning in the air. When you combine that with a property called entanglement, quantum systems can run parallel calculations with exponential efficiency. Basically, they're playing a completely different game. And that brings us to this highly critical definition, the CRQC, or cryptographically relevant quantum computer. For decades now, our financial infrastructure has relied on mathematical algorithms like RSA and ECC. Classical computers would take, thousands of years to break those. But a CRQC, with all that exponential processing power we just talked about, it could crack those foundations instantly. When this machine finally arrives, the core security mechanisms sustaining our global financial operations risk becoming completely obsolete. Moving right along to Section 2, harvest now, decrypt later. And guys, this is where we have to confront a pretty chilling reality. Because the truth is, we don't actually have to wait for a fully operational quantum computer to be in danger. Malicious actors are already using a strategy called harvest now, decrypt later. The steps are simple, but they are devastating. Adversaries intercept classically encrypted data today, and they just store it in massive data centers, kind of like malicious digital hoarders. Then, they simply wait for Q-Day, the day a functional CRQC becomes available. Once that happens, boom, they decrypt and exploit the information. For banks handling mortgages, strategic plans, or loan records that have a shelf life of decades, the security compromise has effectively already happened. The decryption is just delayed. When you map out the systemic risks here, it brilliantly illustrates the stakes. If malicious actors decrypt our financial history and intercept current transactions, we aren't just talking about a few stolen passwords. We are looking at a massive cascade effect across interconnected networks. Literally, the potential for digital bank runs, severe liquidity fragmentation, and a catastrophic, permanent loss of investor confidence. Now, what's really interesting about this is how Mosca's theorem perfectly frames our timeline. It gives us a very simple equation. The time needed to migrate our systems to quantum-safe security, plus the time our data needs to actually remain protected, must be strictly less than the time it takes for a quantum computer to be built. If those first two take longer than the arrival of the CRQ, well, our financial system is entirely exposed.
Okay, Section 3, the quantum cryptography toolkit. It is time to shift from the problem to the solution and introduce the two primary tools financial institutions will use to fight back.
Financial institutions are largely looking at two major solutions here. First up, we have PQC, or post-quantum cryptography. This is a software-based approach. It replaces our currently vulnerable math with incredibly complex lattice-based mathematical problems that are actually designed to run on our existing IT systems. It's highly scalable, and frankly, it's our best near-term fix. Then on the flip side is QKD, quantum key distribution. This is a hardware solution. It uses actual quantum physics and particles to exchange keys. If anyone even tries to eavesdrop, the physical state of the particles changes, immediately alerting the system. It's perfectly secure. But it's much more expensive and definitely a longer-term deployment.
Because these technologies, especially those PQC algorithms, are still being actively standardized by agencies like NIST, banks have to master this crucial concept, crypto agility. Since the standards are still evolving, institutions literally cannot afford to hard-code their security anymore. They must build infrastructure that is flexible enough to seamlessly swap out cryptographic algorithms the very moment a new threat or standard emerges.
In Section 4, I want to reassure you that this isn't just science fiction. Major financial players are already deploying these exact defenses in the real world today. Take this groundbreaking pilot from HSBC, for example. They successfully tested the very first application of quantum-secure technology for tokenized physical gold on distributed ledgers. They used PQC algorithms to safely convert gold tokens into ERC-20 fungible tokens, moving them across secure networks. And to go even further, they partnered with Quantinuum to use quantum origin. That uses a trapped ion quantum computer to inject pure mathematically unpredictable quantum randomness right into the key generation.
I love this quote because it perfectly captures what HSBC achieved with that quantum randomness. The cryptographic keys function like a lock that changes its combination randomly and continuously. Just think about that. Even if an attacker had a future quantum computer, trying to break a lock that is fundamentally unpredictable and constantly shifting, it's an impossible task. It keeps digital assets exponentially safer.
Here is another amazing pilot. Project LEAP, initiated by the Bank for International Settlements, successfully established a quantum-resistant VPN IPsec tunnel between central banks. What's absolutely critical here is that they used a hybrid encryption approach, combining traditional algorithms with post-quantum protocols. This proves without a doubt that we can secure highly sensitive central bank communications without disrupting current day-to-day operations.
And hey, it's not just the software side seeing all the action. Hardware-based quantum key distribution is also moving out of the lab. Danske Bank completed a live QKD-protected data transfer between simulated data centers, making it the very first quantum-safe data exchange in the Nordics. This demonstrates that using the physical laws of quantum mechanics to catch eavesdroppers in real time is a totally viable future for our banking networks.
Which brings us to Section 5, the Quantum Migration Roadmap. We've seen the threat, we've explored the tools. Now, let's build the blueprint for survival using a risk-prioritized framework.
So, the crucial point is how you actually execute this transition. Here is the condensed 6-step roadmap based on the CISA framework. Step 1 is automated discovery. IT leaders absolutely must scan all networks to inventory every single algorithm in use. Step 2 is prioritizing risks based on what data has the longest shelf life. Next, you formulate strict policies and train your workforce while auditing your third-party vendors. Then, run hybrid sandbox trials combining the old and the new cryptography. Finally, Step 6 is agile production integration with continuous monitoring. It is a massive, highly structured undertaking. And I really want to emphasize the sheer scale of this undertaking with this massive number right here, 20 billion. According to the Financial Services Information Sharing and Analysis Center, that is the estimated number of devices globally that will need to be migrated to quantum-safe cryptography. We're talking every ATM, every payment gateway, every secure server on the planet. The logistics are just staggering. Which leaves us with this final, provocative thought. The quantum era is arriving. Is your infrastructure ready to make the leap? The harvest now, decrypt later clock is already ticking. And as we've seen today, the solutions are quickly moving from theory directly into real-world banking environments. Don't wait for Q-Day to find out if your data is actually secure. The time to start your quantum migration is right now. Thank you so much for joining me for this explainer, and I really hope this provided the clarity you need to confidently face the quantum future.